Hi everyone, welcome to today's presentation. Today we are going to look at area approximation, and the question is on trapezium rule. We are looking at KCAC 2011, paper 1, question number 21, and the question reads, using the trapezium rule with 7 ordinates, estimate the area of the region bounded by the curve y is equal to negative x squared plus 6x plus 1. The lines x is 0, y is 0, and x is equal to 6. Then part B will answer these. Calculate Roman 1 the area of the region in A above by integration, and finally the percentage error of the estimated area of the actual area of the region correct to 2 decimal places. Now for the first part, using trapezium rule with 7 ordinates, estimate the area bounded by these lines and the curve. So I'll begin by, first of all, getting the width. The width here is for each trapezium in the partitionings that we'll have. So we determine this by taking the extreme values. We have x is 6 and x is 0. Let's subtract them, and then we divide by the number of strips. For this case, we are told 7 ordinates, but not strips. For trapezium rule, the number of ordinates should be more than the number of strips by 1. So when we are told 7 ordinates, we mean 6 strips. So we divide by 6, and that is 1. So with this, we can partition as follows. So let's have the curve as that. The line x is 0, that is the y-axis, and the line y is 0, that is the x-axis. And then we'll finally have the line x is 6 by the time we're done partitioning. Remember, beginning from x is 0, we need to consider a width of 1 from 0 to 1, another width of 1 from 1 to 2, then 3, 4, 5, and finally 6. So in the mid-ordinate rule, we are going to get these values: y when x is 0, y1, y when x is 2, y3, y4, y5, and y6. So we'll consider that in the formula. Area is equal to a half h into the first value of y plus the last one, and then the ones in between will be doubling, so we multiply by 2, y1 plus y2 plus y3 plus y4 plus y5. So in order to use this, we need to come up with a table, and in this table we'll have the values of x and values of y. So the values of x will range between 0 and 6. We have x is 0, 1, 2, 3, 4, 5, and finally 6. So we are going to use the equation of the curve, which stated y is equal to negative x squared plus 6x plus 1. So that is what we use here, negative x squared plus 6x plus 1. So we are going to do our substitutions in this equation here. So the value of y when x is 0, when we substitute, we need to get 1. When x is 1, we need to get 6. Here we get 9, here 10, here 9, here 6, and here 1. So that is when you do your substitutions correctly. Now we are going to substitute these values here in the trapezium rule. So area is equal to a half times h, and h we had here as 1. So times 1 into y0 and y6, that is these values here, y when x is 0 and y when x is 6, that is 1 plus 1, plus twice the middle ones, 6 plus 9 plus 10 plus 9 plus 6. This is 0.5 times, so we have 2 plus 40 times 2, that is 80. So 80 plus 2, that is 82. So that we have 0.5 times 82. That should give us 41 square units. Now with that done, we can now look at the second part, area of the region in A above by integration. Now, when you get the area by integration, remember we have to integrate the equation of the curve. Just a reminder, this is y is equal to negative x squared plus 6x plus 1. And this line here represents x is equal to 6. This line here is x is equal to 0. And therefore, we were getting the area under the curve bounded by those lines. Okay. At this point, in order to get the area by integration, we're going to integrate from the value of x is 0 up to the value of x is 6. So we begin from 0 to 6 for the values of x. And we are going to integrate this function here, negative x squared plus 6x plus 1 with respect to x. So that means we are going to have, when you integrate this first part, we have negative x cubed over 3 plus, this should give us 3x squared plus x plus c. That is for the values of x is 0 up to x is 6. Next, when we do our substitutions, we will have, substituting the values of x, or rather 6 here, we have negative 6 cubed over 3 plus 3 into 6 squared plus 6. I'm ignoring c because in the end when you subtract, c will just disappear. Okay, and then we subtract, when we substitute x for 0 here, everything will disappear, everything will become 0, so just subtract minus 0. And then at this point here we have, this should give us negative 72. This one is plus 108 plus 6. So this will be 114 minus 72, that is 42. 42 square units. Finally, the percentage error of the estimated area of the actual area of the region, correct to 2 decimal places. The percentage error is obtained by having the error in the area, and the error in the area is obtained by simply getting the difference between the two areas, the estimated area and the actual area. Actual area is 42 square units and the estimated area is 41 square units. So the error there is just the difference, 42 minus 41. And then you'll have to divide that by the actual area, and the actual area is 42. And finally, you multiply by 100 so that you get the percentage error. So this is relative error times 100. When you work out this, you should be getting, so this is 1 over 42 times 100. That should give us 2.3809524, which is approximately 2.38%. That is to 2 decimal places. With that answer, we have come to the end of the solution to this problem. Thank you for watching. See you next time.